In this lesson, we're going to be discussing while loops. Our lesson objectives: learn what a while loop is, and then we're going to learn how to construct the while loop. So let's first talk about iteration in Java, since while loops are our introduction to iteration. Iteration is basically the repetition of a process. So if you want a program to repeat the process of a certain function or a certain piece of code multiple times, then we have to implement some type of iteration. And the iteration that Java has, for example, are for loops and while loops. Now, it's not confined simply to for loops and while loops. However, these are like the main ones that we'll be discussing. So what is a while loop? A while loop is a type of iteration that executes as long as its Boolean expression evaluates to true. Think of it as an if statement initially. So we have a Boolean expression, and if that Boolean expression evaluates to true, then it will execute. And as long as that Boolean value is still true, then it will keep on executing until that Boolean value turns false. To stop it from infinitely looping, we have to implement some type of loop control variable that alters the loop or the Boolean expression that allows the Boolean expression to eventually be evaluated to false. Because if it's constantly being evaluated to true, then the loop will constantly execute because, well, the Boolean expression is still true. And it will only end when that Boolean expression evaluates to false. So this is our while loop. While is our keyword, and then in parentheses we have some type of Boolean expression, and if it evaluates to true, then it executes the Java statements here. Now, as long as the Boolean expression evaluates to true, the loop will continue to execute. So once it's done executing these Java statements, what it will do is it will go back to the Boolean expression, and if it still evaluates to true, then it will execute. Go back, true, execute. Go back, oh, now it's false, now we're not executing. And you're probably wondering, how does it eventually evaluate to false? We have to put some type of code here within these curly brackets that enables the Boolean expression to eventually evaluate to false. And we do that through a loop control variable, as you will see later. So let's look at practice problem number 1. I declared integer I and I set that equal to 0. Integer I will be serving as our loop control variable. Now, we have our while loop because we use the while keyword, and then we have a Boolean expression with the relational operator. So as long as I is less than 3, please keep executing this. So we're telling the program, as long as I is less than 3, I want you to print out I. So we're like, all right, while I is less than 3. So it functions as an if statement initially, you could say. So it's like, all right, is I less than 3? 0 is in fact less than 3, so I want to print out I. So it prints out 0. Then we alter the loop control variable, and then I is no longer 0. I is now 1. So we go back to the while because we're done with the while loop, and now we're going back here because as long as it's evaluating to true, it's going to keep on going. But if it evaluates to false, then it will end. So it goes back and it's like, all right, is I less than 3? Well, because of this increment operator, I is no longer 0. I is now 1. So is 1 less than 3? Well, yes, 1 is in fact less than 3, so it prints out 1. I gets incremented again, so I is now 2. Is 2 less than 3? 2 is in fact less than 3, so it prints out 2, and then increments I again. Finally, we reach 3 is 3 less than 3, because I, now after incrementing it, is 3. So is 3 less than 3? No. 3 is actually equal to 3, and we don't have a 3 equal to 3, or nor do we have a 3 less than or equal to 3. So this evaluates the false, and our executed function, or rather our executed outcome, will be 0, 1, 2. As you can see, it keeps printing, it keeps executing the while loop as long as it's true, but once it reaches false, then it stops. So it doesn't print out 3. Once I was 3, it was like, nope, I'm not executing the while loop. And we have some sort of function, such as the increment operator, that allows the Boolean expression here to eventually be evaluated to false. Alright, let's look at practice problem number 2. Integer I is equal to 0. That's going to be our loop control variable. Then we're going to look at the while loop. While loop I is greater than 5. As long as I is greater than 5, it will keep on getting incremented. So is I greater than 5? it will always be looping. So as long as I is greater than 5, then we'll continue looping. So is I greater than 5? 0 is greater than 5. 0 is not, in fact, greater than 5. So that should be nothing, because nothing will get executed. In this case, you could sort of say it's like an if statement, because this thing now evaluates the false. So nothing gets executed here, in fact. This has to be evaluated true just once for this to be executed once. And if it continues to be executed, then if it continues to be evaluated true, it will respectively evaluate, or rather execute these functions the same amount of times. But since this was a false statement right from the get-go, then nothing gets executed between the while curly brackets. And let's finally look at practice the problem number 3. We have an integer I, and this time we have it set to 1. So integer I in this case will be our loop control variable, because we put that within our parentheses for our Boolean expression. So while I is greater than 0, I want the while loop to continue executing or printing out I and then incrementing it. So integer I is equal to 1. While I is greater than 0, is I greater than 0? Is 1 greater than 0? Yes, it is. So it prints out 1. All right, I gets incremented. I is no longer 1. I is now 2, because I increment means that it's increasing I by 1. So it goes here. Is 2 greater than 0? 2 is in fact greater than 0. That is a true statement. So we print out 2. Alrighty, let's do that again. Let's increment it again. I is no longer 2, I is now 3, because we're incrementing it by 1 through this operator. Alrighty, let's go back to the while loop, or the Boolean expression. I is greater than 0, 3 is in fact greater than 0. So now we have 1, 2, 3 printed out. Now I want you to think about this. Since I is greater than 0 and we keep incrementing this, will this ever be evaluated to false? No, it won't. This will be an infinite loop until the compiler crashes, until the compiler's like, oh my god, I'm done with this. It's going to continue doing it until it crashes. And this is because although we have a loop control variable, the loop control variable is almost like it's useless, because it doesn't allow the Boolean expression here to be evaluated to false at any time. Instead, it just keeps increasing I. If you want this to be effective, then we should have had it decrementing. We should have had the 2 minus operators, because then eventually this thing would have been evaluated to false. But since 1 is inherently a positive number, since 0 is the bridge between positive and negative numbers, since 1 is inherently a positive number, and we want something for this to execute to be always a positive number, and then we keep increasing the I by 1, then we're always going to have integer I will always be a positive number, meaning that integer I will always be greater than 0. So this while loop will continue executing until the compiler's like, I'm done with this. So this will be an infinite loop, and we want to try our best to avoid infinite loops within our program, because not only does it ruin the resource, not necessarily ruin the resources, but the compiler cannot handle it, or eventually it will crash. We will have an overflow error. Alrighty, so let's do 4 different programs that allows us to utilize while loops. So I'm in the compiler, and let's create a while loop that prints out the values 0 to 10. So let's first create my class. Public class while loop practice. Then we have our curly brackets. And then our end curly bracket. Then we have to declare our main method. So public static void main string arguments. And then we have our opening curly bracket and end curly bracket. Alrighty, so if we want to create a program that prints out the values from 0 to 10, then we need to have a loop control variable that starts at 0, and then our Boolean expression should evaluate the true until the numerical value 10. So let's first start, well, let me first intent actually. Let's first start by declaring integer I to be 0. Now, let's create our while loop. So we want this value to keep on looping until integer 10. So what we do is that as long as I is less than or equal to 10, then I want you to print out I, because I will keep getting incremented once we increment it through the increment operator. So what I've done with this algorithm is that I've had a loop control variable, and the loop control variable allows me to say, hey, as long as I is less than or equal to 10, then we want to print out I, and then we want to increase I. So I starts off small, starts out as a 0, but then through the while loop, because since it's less than 10, or less than or equal to 10 rather, more specifically, it keeps getting incremented. So it's like, all right, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then once it reaches 10, then it's like, all right, let me increment I. I is now 10. And then, sorry, I is now 11. It goes here. Is 11 less than or equal to 10? No, it's not. So the while loop then ends, and then the program ends since we have nothing after it. So let me first save the program. Alrighty, so we save the program, and then let's run it. Alrighty, and there you go. So it prints out 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, if you don't like how it's listed like this, then we can replace that with a print statement. Instead of having an ln statement, we have a print statement. And then we have to add that space so it's not all congested together. So we have that space. And there you go. It prints out 0 to 10 in case you did not want to scroll through all that messiness. So 0 to 10. Now I want you to alter this program so that it can list the numbers 0 to 30, but it does it by fives. So it goes 0, 5, 10, 15, all the way up to 30. So please try that out. Alright, I hope you managed to do that program. I'm going to keep the same loop control variable in this case, but instead of having I is less than or equal to 10, I want I to be less than or equal to 30. Now you're probably thinking, all right, if I execute it like this, won't this just do it until the number 30? Well, yes, it is going to do that until the number 30, but now we have to change how much we're altering the loop control variable by, because we're using the loop control variable for two different functions. We're using it first and foremost as a loop control variable, but we're also using it as a way of providing output to the user. So we're providing the number output to our user. So we're utilizing I for those two cases. You know, you can utilize two different variables in that case, but to make life easier for us, we're just combining that together. So instead of increasing I by 1, I'm now going to increase I by 5. So it's like, all right, instead of incrementing by 1, I'm going to increment I by 5. And that's how you increment I by 5, if you remember from our arithmetic operator episode lesson. And there you go, 0, 5, 10, 15, 20, 25, and then ends with 30 because we have less than or equal to 30. And if we had less than, just less than, then it would have stopped at 25. So now I want to make an algorithm that computes the total of the numbers 0 to 10 and then prints it out to the user. And this might be very tricky at first because what we've been doing is that we've been utilizing the integer I as our loop control variable and the way of, providing output to the user. But in this case, you might need to make two variables. So I'm going to let you try that program out as of right now. I'm going to let you try out the program, and then we're going to do the solution after you unpause the video. Alrighty, so I'm going to erase this. And what I'm going to do is I'm going to still have integer I as my loop control variable. And when I'm computing the while loop, I want to make sure that I is still in control. So what I'm going to do is that I want to make sure that I only loops by 10. And then once it's done looping 10 times, then I want the program to end. So I'm going to make my while loop, and then I'm going to have I has to be less than or equal to 10. And then I'm going to have an increment operator. Alrighty. So what this algorithm does is that we declare a loop control variable, and then it will compute this while loop 10 times. That means that it's going to execute 10 or 11 times, considering that 0 is part of it. So if we're counting 0, then technically it will be 11 times. But for the sake, it's going to go up till 10. And we want to get the sum of all values of from 0 to 10. So the way we do that is by creating another value. So we're not utilizing it as a way of providing output to the user, because now I is only being, in this case, being used for a loop control variable. It's not being used to provide output to the user, but it can be used within the calculation. So what I'm going to do, since we're making a program that calculates the total of the numbers between 0 and 10, I'm going to create another value, or rather another variable, and it's going to be called integer total. And we're going to store the total of, let me set that value to 0 so it's declared, because that was only a declaration statement. Now we've assigned the value 0 to total. So now what I want to do is that I want this to be not incremented, but every time the while loop executes, I want I to be stored or added into total. So when I gets incremented to 1, I want total to increase by 1. When I gets incremented to 2, I want 2 to be added to total, not become total. I want it to be added to total. So then it would be 3 in that case, right? Because 0 plus 1 plus 2 is 3. And then similarly, when we go up to 3, then I want to be 0, 1, 2, and 3. Add those numbers together, and we should have 6. So what I'm going to do is total. The new total is going to be equal to the old total plus I. Alrighty? So just so that I can tell you, or it makes sense to you, is that we have an integer I which is equal to 0, and we have an integer total that is also equal to 0. Integer I will be our loop control variable. This controls the while loop so that it only gets executed 10 times, or rather 11 times. But again, it's supposed to control the loop. Then the total we serve as our way to add or combine all the numbers together. Every time it gets executed, we want total to be increased by the new number of I, because I gets incremented every single time, and we're trying to get the total of the numbers 0 to 10. So it's like, all right, is I less than 10? All right, I is less than 10, so 0 is equal to 0 plus 0. So total is 0, I is 0. Now then I gets incremented, so now that I gets incremented, it's now 1, and total is still 0 at this point. So now we're like, all right, is 1 less than or equal to 10? 1 is in fact less than or equal to 10. So the new total is equal to the old total, which is 0, plus I. I, in this case, is now 1. So now the total, or the new total, is now 1. And then it continues that all the way up to 10. Let me compile it. Oh, and let me add a print statement to show you what the new value of total is by the end of our algorithm. And there we go. That should be the correct answer. The sum of the numbers 0 to 10 is in fact 55. Now, how do we see that change of total all the way up to 55? Well, we can implement a print statement within our while loop to show the progression of the value total until it reached 55. So what I'm going to do is I'm going to print out system.out.println total within the loop. So whenever the while loop gets executed, it's also doing a print statement that shows the new value of total every time the while loop gets executed. And I want this to be a print statement because I want this to be all on one line. And let's add that space so it doesn't get congested. And since this println statement starts it off on a new line after you've printed it, we have to put another println statement here so it starts on a new line. There you go. And as you can see the progression of the value total every time the while loop gets executed. So when the while loop gets executed the first time, the value of total is still 0. And it's only because both I and total at the beginning are 0. So when you add 0 plus 0, you're obviously going to get 0. But then I gets incremented. And then I is like, all right, I'm not a 0 anymore, I'm a 1. So it's like, all right, 0 plus 1. Total is now 1. So now we have 1, 1, and then I gets incremented to 2. 2 is in fact less than 10. So we're like, all right, what's the old total plus the new value? 1 plus 2 is 3. So our new value is 3. And it keeps doing that. It keeps adding the value of I at that case to total. Total doesn't become the value of I. The value of I is simply added to total. And then we eventually get 55 as our total of the numbers 0 to 10. The sum of the values between 0 and 10 is 55 inclusive. Alrighty, now before my next task for you, I want to tell you what a factorial is. So you might know about this from your math class. Basically, a factorial is a function that says to multiply all whole numbers from your chosen number all the way down to 1. What I basically mean by that is, say that we have 3 factorial. If we have 3 factorial, that's basically the same thing as saying 3 times 2 times 1, which is the same way of saying, and I'm going to only emphasize this because I want you to make a factorial program, but as of right now, I'm just going to show you what a factorial is. The reason why I'm saying you could write 1 times 2 times 3 is because maybe that's the logic you might have to use. And then that will compute to 6. So these are 2 ways of writing a factorial. Well, rather a bunch of ways to write a factorial, but this is the main way you write a factorial. This is the second way you can write a factorial, 3 times 2 times 1. This is the one that I want you to look at more specifically because this is what you might implement into your program. And then the evaluation is ultimately 6 because when you multiply 3 times 2 times 1, it is 6. If we do, let's say, 4 factorial, it's going to be 4 times 3 times 2 times 1, which is equal to 1 times 2 times 3 times 4. And then that is equal to 24. Because 1 times 2 is 2, 2 times 3 is 6, and then 6 times 4 is 24. Alrighty? So I want you to make basically a program that takes a user input, that takes an integer from the user, and then computes the factorial of that value. So I want the users to say, hey, if I enter 3, then the result should be 6. If a user enters 4, then the result should be 24. So I want you to try to make a program like that. Alright, so I hope you managed that. Let's first create our scanner. Well, let's first import our scanner, because the scanner is not native within it, so we have to import, we have to get it in there. Or we could just simply use the asterisk. So scanner, my scanner is equal to new scanner system.in. And that's how we make a scanner, or a way of getting user input from the user. We declare the scanner, we assign a scanner into the scanner object. Now we got to tell the user, because we are getting user interaction, enter an integer. Alrighty, now we need to get the user input. And the user input is probably going to be an integer. Well, it has to be an integer because we're telling it to enter an integer. So we first declare an integer where our input integer is going to be stored. So integer input is equal to, then we utilize the scanner. So we have their scanner name, and then we utilize a method that only gets integers because, well, we're getting an integer and we want to make sure we get only an integer. Alrighty, now that we've gotten the input, this will serve as our way of controlling the loop. It's not going to be our loop control variable, But like in the last one, it sets our maximum value. So remember when we were looping our while loop 10 times specifically, or 11 times? I keep mixing that up because we're including 0. But the reason that value of 10, which was our max, to make sure that the while loop doesn't go that many times, well, that is going to be our max. Our input is now going to become our max. Our loop control variable is going to be integer I, and we're going to set that equal to 1. And then we're going to have an integer total, and that's going to equal 1. Now, there's a specific reason why I didn't do 0, and the reason why is because any factorial, well, we can have decimal factorials, but the reason we're doing integers right now. But just for the sake of it, a 0 integer, a 0 factorial is 1. Now, I know that's very weird. Why is 0 factorial 1? But just for you know, the base form, 0 factorial, is equal to 1. 1 factorial is also equal to 1. 2 factorial is when it starts getting increased. So 2 factorial is now 2 because 2 times 1. But just know that the base scenario, 0 factorial and 1 factorial are equal to 1, which is why I have the total equal to 1, because every integer factorial that is greater than 0 is going to be at least 1. So we're setting total as our base value. So 1 is in total because 0 factorial and 1 factorial are 1. So now we create our while loop. And then in the Boolean expression, what we do is we have our loop control variable, because this is what integer I is going to be what gets altered within the loop. Total will also get altered in the loop, but it's not going to be the change. It's not going to be the Boolean within the Boolean expression of whether or not the while loop should continue executing. And then it's going to be less than or equal to the input, because we want the while loop to execute the amount of times that the user has requested. So if the user says, I want a factorial of 4 factorial, then input would be 4. So the while loop will execute 4 times. Then we put in an algorithm. So total is going to be equal to total, the old total, times I. Now, if you're a really math person, you notice this right now. Let's say if we had total equal to 0. Well, if total is already 0, then anytime we multiply 0 with any number, then it's going to continue to be 0. So when we print out total for the last time, it's going to be 0 because we keep multiplying it by 0. So that is another advantage of having 1 here. Now, I'm going to increment I every time the loop gets executed. And then I want to print out I. Now, before I explain what's going on within this program, I'm going to see whether or not it works. So we know that 3 factorial is equal to 6, and 4 factorial is equal to 24. So let's add 3. And we get 6. That's good. Let's run this again. And let's do 4. And then it prints out 24. So what is happening every single time that we are executing this function? Well, let's see how total changes when we keep going. So we utilize a print statement, and we're gonna see how total changes every single time that the while loop gets executed. And then once that gets executed, I'm gonna tell you how the while loop allows us to reach that certain factorial. And then I'm gonna add a print statement to separate the line here, the line that gets executed within the while loop, and then the final line. So let's say I put 4 factorial, or don't put like the exclamation point, just put enter the integer. And as you can see, this is what happens to the value total every time it gets executed. And that was the reasoning that I was trying to explain to you. Although I can write 4 factorial as 4 times 3, I wrote a dollar sign, 4 times 3 times 2 times 1, maybe it's a little bit easier to think of it as 1 times 2 times 3 times 4. and then that gets evaluated to 24. So what this compiler does is that it's like, all right, integer I, our loop control variable, is that less than the input? Well, my input was 4. So for the premise of this video, I'm going to keep referring to input as 4. Integer I is equal to 1. So is 1 less than or equal to 4? Yes, 1 is in fact less than, or rather I is less than or equal to 4. So it's like, all right, what is the total? Total is 1, and then we multiply that by 1 because I is now 1. So our value of total is still 1 because 1 times 1 is equal to 1. And then it prints out 1 within our print statement. And then it increments I. So I is no longer 1. I is now 2. Alrighty. Is 2 less than or equal to 4? 2 is in fact less than or equal to 4. So it's like, all right, total. Our new total is equal to the old total, which is 1, and the new I, which is 2. So it's like, all right, 1 times 2. 1 times 2 is 2. So total is now 2, and it prints out 2. Alrighty, total is now 2. And then it increments I again. So I is no longer 2, I is now 3. Is 3 less than or equal to 4? 3 is in fact less than or equal to 4. So the new total is equal to 3, or rather the total. So the total is 2, and I, which is 3. So 2 times 3 is equal to 6. So total is now 6, and it prints out 6. Now we increment I again. I is now 4. Alright, is 4 less than or equal to 4? Yes, 4 is less than or equal to 4 because we have that equal sign over there. So now, since 4 is equal to 4 technically, this is still a true statement. We're going to execute. So total is equal to total times I. Well, the total is 6 and I is 4. So 6 times 4 is equal to 24. Total is now 24, so we print out total. We print out 24. Alrighty, we increment I again. I is no longer 4. I is now 5. Alrighty, is 5 less than or equal to 4? No, 5 is not less than or equal to 4. So this while loop then finally ends. It doesn't get executed again. So we're like, alrighty, let's print out the total because now the while loop is done. So it goes to the next line. Start a new line with this statement, and then it prints out the total, and the total is 24, which is our factorial. So basically, that process was like, all right, 1 times 2 times 3 times 4 on the last time, and during the last loop. And that's basically how to make a factorial program within Java. That's the type of thinking that you have to utilize when you're making programs, specifically with control structures or iterations. There's a different decision. There's a different way of thinking when it comes to computer science, and everything has to be taken literally. Some things that you take for granted, the computer is not going to take for granted. So everything needs to be pretty well calculated. So I could have made a mistake where this could have been an infinite loop, or even in some other case or some other mistake, I could have made it so that this while loop could never be executed. So these are the type of things you have to think of when you're constructing while loops. So this is a more advanced root of while loop that I've implemented to you. I made it go from, easy, medium to a little bit hard, but I think this sort of covers the gist or the scope, not all of the scope, but a pretty good scope of while loops and how powerful they could be in terms of computations or just basic tasks. And this is our introduction to iteration. Our next lesson, we're going to be discussing for loops, so that should be very exciting.